Everyone, good day. Welcome to Uber Schoolie. Today we are back to answering a question on Chapter 2, Force and Motion. This question shows an image of a rocket being launched. And the question is as follows. Question A. Explain on how the release of hot gases through the rocket's exhaust enables the rocket to accelerate upwards. And B, how can the acceleration of the rocket be increased? So in question A, they are asking us to explain the physics principle that lies behind the launch of the rocket. So let's see what are the physics principles that can be applied for this rocket launch. Moving forward, okay, so if you see this GIF shows that once the exhaust gas is released, it gives some sort of power or some sort of energy for the rocket to move upwards. So this can be correlated to Newton's third law of motion, which says that every action has an equal opposite reaction. If you see here, this free body diagram, that is a rocket. So when the exhaust gas goes downwards, there will be an equal opposite reaction, which basically the thrust force. The thrust force is what makes the rocket to propel upwards. It's the same concept when we, for example, we are playing basketball and we throw the ball to the ground and the ball bounces back upwards. So that is basically the same concept as how this rocket is being launched. So the exhaust gas, remember, the exhaust gas is basically the action and the thrust is the equal opposite reaction. So this is how you explain the rocket launch based on Newton's third law of motion. Besides Newton's third law of motion, we can also apply principle of conservation of momentum to this rocket launch. Momentum is the product of mass into velocity. When we speak about principle of conservation, it states that the initial momentum has to equal to the final momentum. So applying this to our case, the initial momentum of the rocket is basically when the rocket is at rest state before the launch. And the final momentum would be the momentum of the rocket after launching. Let's see the momentum of the rocket before the launch. Before launch, we know that our velocity is equivalent to 0 because the rocket is at rest state. This means our momentum before the launch is going to be equivalent to 0. Now, moving forward to the after launch, what happens is that we have to take account two things. First is the thrust and second is the exhaust gas. So I have denoted my thrust as P1. P1 is momentum of my rocket body, which is M1 and V1. And the next thing is my exhaust gas, P2, is equivalent to M2 multiplied with negative V2. Why is it negative? Basically, it's because it's going in the opposite direction of the thrust. That's why there is a negative. So my total final momentum is going to be M1 V1 minus M2 V2. Going back to just now's equation, we have before launch, our momentum is equal to 0, and after launch, our momentum is equals to M1 V1 minus M2 V2. So equating both of them, we are going to get this equation. 0 is equals to M1 V1 minus M2 V2. So if you rearrange, you are going to get this equation, M1 V1 equals to M2 V2, which simply translates to momentum of the rocket body is equivalent to the momentum of the exhaust gas in the opposite direction. Okay, so I think this is clear. So let's go to how I'm going to present the answer for question A. First, the principle lies behind Newton's third law of motion and also principle of conservation of momentum. According to Newton's third law of motion, every action has an equal opposite reaction. As the exhaust gas rushes downwards with high velocity, this creates a thrust force to allow the rocket to move upwards. Principle of conservation of momentum states that the rocket's momentum is equivalent to each other before and after launching. Since before launch the rocket is at rest, the initial momentum is 0. Thus, equation below is governed. Momentum when rocket before launch is equivalent to momentum after the rocket being launched. So 0 is equals to M1 V1 minus M2 V2. Rearranging this equation, we are getting M1 V1 minus M2 V2. And this shows that the momentum of the exhaust gas is equivalent to the momentum of the rocket moving upwards. Moving forward to the next question, how can the acceleration of the rocket be increased? Here, we are going to apply Newton's second law of motion, which is F is equals to ma. Force is equals to product of mass and acceleration of a body. So here, using the same free body diagram, we have two forces here. First is the thrust, and next is the exhaust gas. So, since we know that the force of the thrust is equivalent to force of the exhaust gas, we can come up with this equation m1a1 is equals to m2a2. Rearranging this equation, we are going to get that a1 is equals to m2a2 divided by m1. m1 is basically the mass of the rocket. So, in order for us to increase the acceleration of the rocket body, we can either decrease the mass of the rocket body, or we can increase the acceleration of the gas and also the mass of the exhaust gas. So let's see what are the recommendations that I can give you in order to increase the acceleration of the rocket. First, use light mass material because lower mass yield to higher acceleration. Like I said to you, since our mass goes down, our acceleration can go higher. Next, improve aerodynamic because it can reduce air friction. So if the rocket has a more aerodynamic body, we can reduce the air friction that acts on the rocket body, which means the rocket can propel faster, which can increase the acceleration. And the last thing is to use a multi-stage rocket. So when we have a multi-stage rocket, it's basically every stage they have their own burning fuel, pump, and combustion chamber. So once each combustion chamber has burned out all the fuel, so we just throw away that particular stage, which means we reduce the mass of the rocket in total. So this is called as rocket staging. I'll show you a GIF for this. So you can see here this rocket is moving forward, moving upwards, right? So once the gas already finished, it released this particular section, which means the rocket loses some sort of mass and the acceleration of the rocket is increased. Okay, so that's all for today. Thank you for watching the video. Please like, share, and subscribe to our channel. And if you need help on any physics question, feel free to post your questions in the comment section. Till we meet again, have a nice day. Bye bye.